The intermediate value theorem. So we're going to just draw some graphs and get some intuition about the intermediate value theorem. So let's say we've got this function that is continuous on the interval a to b. So if you don't know what continuity is yet, go ahead and go back and read section 1.7 before you watch this video. But as a reminder, continuity means if f is continuous on the interval from a to b, it means there's no breaks, no jumps, that I could draw the graph of f from a to b without picking up my pencil. So if f is continuous from a to b, that would mean, okay, maybe here is f of a. The f of a is its y value, so here's the point a, f of a, and maybe right here is the associated point with b, so that's its y value, f of b. So if I'm drawing the graph of f, that means I can't pick up my pencil at all, or in this case, my stylus on the iPad. I don't know what it does, but I can't pick it up at all. So by the way, this portion in the middle, I meant for this to be a function, so maybe that's ever so slightly moving to the right. It's supposed to pass the vertical line test, so just give me that there. All right, so what the intermediate value theorem says is that if I have any number between f of a and f of b, let's just call that L. If I am going to find, intermediate value theorem says I'm going to find a point on the graph of f with that L value. So what that means is there is an associated x value c between a and b with this y value, no matter what. And that's going to be true for every value L between f of a and f of b. That doesn't mean I might have y values outside of f of a and f of b, like here, but the intermediate value theorem doesn't guarantee those. What it guarantees is all y values between f of a and f of b have a point on the graph of f, because I couldn't jump over it. I was not allowed to jump over it. So let's actually write the statement of the intermediate value theorem. Okay, so the intermediate value theorem says if f is continuous on the interval from a to b, that was our assumption that we started out with, then for every L between f of a and f of b, that's this guy right here, every y value between f of a and f of b. And I have to say it this way because I don't know if f of a is bigger than f of b or f of b is bigger than f of a. I could have had the reverse, so I can't use interval notation here because I don't know which one's smaller and which one's bigger. I can't use inequality signs because I don't know which one's bigger and which one's smaller. Okay, so for every y value between f of a and f of b, there exists a c, okay, that's the associated x value in the interval from a to b such that, I'm running out of room here, f of c equals L. In other words, there is a point on the graph of f with that L value, so it also must have an x value, and to be a point on the graph, it means that f of c equals L. It doesn't mean that that's the only one, so like for this y value, maybe this is m, it's got three associated x values. All this is saying is that there's one.